Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, power of 3. Now, we are going to solve this particular problem in different methods using different logics, and each logic is going to teach you something. First of all, let's go through the question. So, given an integer n, return true if it is the power of 3, otherwise return false. So, basically, we are given an input, n is equal to 27 or n is equal to 0 or minus 1. It could be anything, it could be an integer, and the range of our input is from minus 2 is to power 31 to 2 is to power 31 minus 1. That's the range of the value of n. Now we need to either return true or false depending upon the condition that the given input n is a power of 3. When we say it is a power of 3, it should be 3 is to power 0, 3 is to power 1, 3 is to power 2. These kind of numbers it should be. So the second line says that an integer n is a power of 3 if there exists an integer x such that n is equal to 3 is to power x. So basically your n can be represented in the form of 3 is to power x. Now this x could be anything but has to be an integer. Now first of all you will have to understand that if the value of n is less than or equal to 0, in that case we are always going to return false, because we have to return false if n is not a power of 3. If we have an integer n as an input and the value is, let us say, equal to minus 3, so now you don't have any number x such that 3 to power x will be equal to minus 3. If you talk about positive values of x, then this value will be positive, right? If you talk about negative value of x, for example, 3 is to power, let us say, minus 2. So this is not negative. It will be equal to 1 upon 9, 1 divided by 9. Basically what we do is we say if the power is negative, we can just put this in the denominator of 1. So we can say 1 divided by 3 is to power 2, which will be equal to 1 divided by 9. So there exists no integer x such that 3 to power x will be less than or equal to 0. Even if the value of x is equal to 0, the first number which will be a power of 3 will be equal to 1. 3 to power 0 is 1, right? So first of all what we can do is we can say if n is less than or equal to x, then in this case we need to return false. Now let's try to solve the problem, and the first method can be, let us imagine a true scenario in which the given number is a power of 3. So when it is 27, it means it is made up of 3 multiplied by 3 multiplied by 3, right? How can you find that there are multiple 3's involved to create this number? If you keep dividing the numbers 27 with 3, let us say divide with 3, it will be equal to 9. 9 is also a power of 3. If you divide 9 with 3, it will be equal to 3. 3 is also a power of 3. If you divide 3 with 3, then it will be equal to 1. So basically you will be able to divide your number by 3, and ultimately it will be equal to 1 at the last. Even if you start with bigger number, let us say for which you are getting a value as true, let us say it is 243, the value will be true, the output is going to be true, because 243 is actually equal to 3 to power 5. So we can say 3 multiplied by 3 5 times, right? This is 5 times. Now if you keep dividing 243 with 3, you will first get 81, then you will get 27, then you will get 9, then 3, then 1. So if you keep dividing your number with 3, you will ultimately get 1, and you will be able to divide your number with 3. You will have no remainder left. For example, let us talk about a false scenario. Let us talk about a number which is not a power of 3, 26. This is not a power of 3. If you divide it with 3, you will get it equal to 8.67 something, right? You will have a remainder left. So from here you can say that this number is not a power of 3. Or let us say it is 24. And if you divide it with 3, it will be equal to 8. What now? You might think that, okay, 24 can be a power of 3 because 3 is able to divide this. But if you divide 8 with 3, you will get 2.67, right? So it will fail here. Or let's say one more scenario, it is 6. 6 divided by 3, it will be equal to 2, right? 2 divided by 3, it will be equal to 0.67. So what we can basically do is we can just run a simple loop. We can say while n mod 3 is equal to 0. That is, while we are able to divide the n with 3, till the time there is no remainder, let's divide n with 3. So n will be equal to n divided by 3, and at last we can say n is equal to 1. Return n equal to 1. Because for numbers which are power of 3, n will be equal to 1 at the last. But for numbers which are not a power of 3, this n will be not equal to 1 in the last. And just before running this, I think this condition has to be updated. This n should be less than equal to 0 and not x. So now it looks good. Now if you can run this, and this should pass your sample test cases. All the sample test cases are passed. Let me submit this and all the test cases will be passed. But this is not the best solution, although you can see the runtime is really good. The memory used is really good. We are not using a lot of memory. The time complexity is also good. But if you see the description of the problem, they say that could you solve it without loops or recursion? So basically they want you to solve the problem using maths. Right now we are using loop, which is a fine solution, but let's actually improve this. So one of the mathematical concept which is actually made for these kind of scenario is called as log. When you take the log of a number n with a base b, then you get a value. Let us say you get the value as p. So this particular formula is representing b to the power p is equal to n. That is, if you raise this b to the power of p, then this will be equal to n. So that is what we are calculating here in the left hand side. Log of n to the base b will be equal to that power, at which if you raise the b, that is b to power p, then it will be equal to n. And exactly that is what we need to do in this particular problem. Here the base is 3. We have the base as 3 because we need to find out that what power of 3 can be equal to n. And we need to make sure that n is an integer, because if you try to find out a log, you will definitely get something as an output as p. But this p can be decimal as well, right? For example, if the value of n is 243, then in this case p will be 5. But when the value of n is, let us say, equal to 240, then in this case we are not going to get any error. We are going to get some value like 4.97 or something like that. So we are definitely going to get an output, but this time it is a decimal, right? So we need to follow this rule, and let's try to solve the particular problem. But before solving it, in Python we have a method to find this left side value, that is, find the log of any value with any base. We can just use the log function, which is available in the math library of Python. We can say log of n, and this is our base. We can directly use this. But in some programming languages, there are no functionalities to find the log of a number n to the base of b. They just have the log of a number with the base of e. This e is a defined value which is approximately equal to 2.71, or they may have a log functionality with the base of 10. It depends upon the implementation in the programming language. But if you do not have this functionality to find the log of a number n with the base of b, then you can use the mathematical formula, which is log of a number n with the base of e divided by log of the number b with the base of e. That is, if you try to find out the log of n with the same base and log of b with the same base, and you divide these two numbers, basically you divide log of n with the base e divided by log of b with the base e, this will be equal to log of n with the base b. This is a mathematical formula. So if you do not have the direct functionality to find out this, but if you have a functionality to find out the log of any number to a defined base, then what you can do is you can find the log of n with the base of e, then divide it with log of p with the base of e. Now let me try to get rid of this while loop and try to solve it using logs. Let me do one thing. Let's say n log is equal to log of n to the base of 3, right? Let me print the value of n log. How can you find if this is an integer or not? If 4.97 is an integer, how can you find this? Basically what you can do is you can take the ceiling value of this, take the upper bound of this. The upper bound will be equal to 5, right? If this number is equal to 5, then we can return true. That is, this number is a defined integer. For example, if you try to find out the log of 243 with the base of 3, then this will be equal to 5.0. If you take the upper bound of this will be equal to 5, and these both are equal, right? And since both of them are equal, we can say that yes, this is a power of 3. But for 240, this will be around 4.97. The ceiling value will still be 5, but this will not be equal to 5 now. Alright, so now let me try to solve the problem. I can say return n log will be equal to ceiling of n log. That is, if both are equal, we are going to return true. If they are not equal, we are going to return false. Now let me run this and let's see if this is able to solve all the test cases. So we can see 5 test cases are fine, but one of them fails. I will show you the failed one. See, when n is equal to 243, then what we are expecting as the output, basically we are printing the value of n log as well, is 5. But in programming, sometimes we have this floating point issues where instead of returning 5.0, they might have a small error like 0.0000001. That could be our error. Like 10 is to power minus 8 can be the error, which is a very small error, but for our code it is a big error, because we are trying to find out the log of 243 with the base of 3. It should exactly be 5.0. Our logic is saying that if this number is not an integer, then this n is not a power of 3, although it is. But here what's happening is n log is equal to 4.9999 something, and ceiling value is 5, and they are not equal. So due to this small floating point issue, we are not able to solve our problem using this particular formula. Even if you try to use the mathematical formula of finding the log of n, not by having this base of 3, because in some programming language you don't have this option, the base is already defined, you cannot customize it. So I can say log of n divided by log of 3. This is exactly like finding log of n to the base of 3. If I run this again, you will see that still we are having this error. Yes, we are able to pass 5 test cases, but the last one is still having the error. See, if you see for small values like 27, it is the power of 3 and standard output is 3.0. That is what we are expecting from this formula. But for 243, this particular test case is failing because the standard output is not what we are expecting, right? How can you solve this? So instead of following this method of log, let's try to understand the input. the size of the input is 2 is to power 31 minus 1, right? So that's the highest value of n I can get. So the highest number in our input will be 2 is to power 31, right? That's my highest number. Now, whatever is my highest number, let me try to find out what power of 3 will be equal to that highest number. And I will tell you the reason. But let us first try to find out. So power of 3, let us say the variable name is PO3, which is equal to log of highest divided by log of 3, right? This is like finding log of highest to the base 3, right? Now, if I print the value of PWO3, let's see what's the value. Let's see what happens. So for 243 or for any value, you will see the output is same, which is 19.5588 something, right? It means 3 is to power 19.558, whatever is this value, will be approximately equal to 2 is to power 31 minus 1, right? That is, whatever is the value of n, if it has to be true, let us say it is the power of 3, then it will not be power of 3 more than 19.558, right? It will be a power of 3 till 3 is to power 19, because 3 is to power 20 is out of the range of our input, right? So let's do one thing. Let's try to find out the highest value for which we are going to get a true. The highest value will be 3 is to power 19, right? Anything more than this will always be false because our input has a constraint, right? Now let's use a simple mathematics. If you have two numbers which are power of 3, let us say we have 243, which is 3 is to power 5, and let us say you have 9, which is equal to 3 is to power 2, right? If you divide 243 with 9, it will always divide, right? You will always be able to divide, and the output will not be a decimal. It will always be an integer, because what's actually happening is here we have 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3. You are trying to divide this with 3 multiplied by 3. So two threes will cancel each other and you will always get an integer. If you divide this, you will never have a remainder, right? The remainder will always be 0. But let us say you divide 243 with a number which is not a power of 3. Let us say you divide it with 8. Then you will definitely have a remainder left. I think in this case the remainder will be 3. So what we can do is we can say return highest, because we know the highest is always a power of 3, because it is equal to 3 to power 19, highest mod n. This will be equal to 0. If this condition is true, it means n is a power of 3, right? That is why it is able to divide highest. If n is not a power of 3, it will not be able to divide highest, and we are going to return false. So this is a simple maths to solve this particular problem. And if I run the sample test cases, all are pass. If I submit this, this is going to pass all the test cases. So you can see the runtime is fine. The memory used is fine as well. So we are able to solve this particular problem without any loop or recursion. But the point is, guys, we are actually using loops and recursion or something like that, because this power function is actually working using loops, right? So I don't see any point of this follow up, but still from our end, we are not using any loop or recursion. So we are able to understand the maths behind this problem, right? So that's it for this video, guys. I have tried to explain you everything which you need to know for this particular problem. And if this video helps you to understand everything, then make sure that you are hitting that like button. And if you have not subscribed to my channel as of now, then make sure that you subscribe to it as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one, guys.